So we've been talking about this word function, but it's kind of helpful to understand what a function is. So the way we actually define function is that it's a relationship in which each input gives only one output. Okay? A function is a relationship in which each input gives only one output. Let me give you an example of that because I think it will help when you actually understand an example. So an example would be your student ID number. If I were to go to the computer system and type in your student ID number, you are the only person that's going to come up because you're the only person with that student ID number. So this would be a function. So then if we talk about a non-example, so something that would not be correct, it would be your name. For example, let's say the name Sarah. I'm just using that as an example. If I go to this computer system and I type in the name Sarah, that's my input. It's not going to give me back one person. It's going to give me back multiple people because there's multiple people with the name Sarah. So those are some examples and non-examples of functions and non-functions. So when you're talking about the salary problem, if you'll think back a couple lessons ago, the salary problem was where I was talking about how much you get paid for your hours of training. Well, in a salary problem, there is exactly one output for each input because you don't work 10 hours one week and get paid $100 and the next week work 10 hours and get paid $400 and the next week work 10 hours and get paid $50. Every time you work 10 hours, you get exactly $100. So in some real world problems, you can get more than one output for one input. That is true. That's the examples of that would be our names. That's a great example of something where you have more than one output for each input. They're going to ask you multiple times about the catwalk problem. You need to know that the catwalk problem always has two outputs for each input. What they're talking about is they're basically asking if you had a wall. Here's a wall. I'll draw an arrow and say that's a wall. And you had a support beam here. So this is a beam. The question is, how many times does it touch? Well, it touches twice because it touches here, it touches the ceiling, and it touches the floor. So it has two outputs. And the outputs represent where it touches. So answering some questions about that, is there at least, we're actually going to skip question 1. Question 2 says, if you limited the input values to those between 0 and length of the catwalk, would there be at least one output for every input? And the answer to that is yes. So in life, we have relations. Every mathematical equation, every graph, every word problem is an example of a relation. So everything is a relation. Functions are special relations. Okay? And the reason they're special is because they have one input equals one output. Like your student ID number. You put in one student ID number, you get out one student. A relation is one input equals one or more outputs. So that means a couple things. That means that if it's a function, it is also a relation. So if it's a function, it is a relation as well. But it means that relations are sometimes functions. So thinking back to our student ID problem that we had earlier, if you input a student ID, you're going to get out one student. That is a function and a relation. But the name problem, for example, the name Sarah, if you put in the name Sarah, you're going to get back a lot of people, so that is just a relation. So in other words, a function is a special relation. You need to write all of this down that I've written on this page. A function is a special relation. So the catwalk problem is a function, or is not a function, but it is a relation. We're not going to talk about the Old MacDonald problem. You don't need to know. Let's go ahead and answer this question at the top. It says, which of the following can describe situations in the real world in which a single input can result in more than one output? And the answer to that is a relation. So a single input gives more than one output. It's always going to be a relation. All right, a couple more things you need to write down. So going back to this notation that we had here, or we've been talking about. So this blank depends on blank, or blank is a function of blank. You need to know that this is your independent. Easiest way to remember that is it's in the parentheses, so it's your independent, which makes the first blank your dependent. Okay. And we would also say that this depends on, so our first blank depends on our second blank. And remember, these are the same. Whatever goes first, whatever's inside the parentheses goes last. We could also say that what's in the parentheses is our input. So it's in the parentheses, it's input, it's independent. What's outside the parentheses is our output, because it is outside. And the very last thing that I would remind you of, and this is going to seem very random to you, but I promise you will need to utilize it on your test, is that your area is equal to your length times your width. That will be beneficial.